I was working already 10 years at Penn. Actually, I was working at cardiology, which was Department of Medicine, but I moved to neurosurgery. But I still keep coming back to my friends and using also the Xerox machine because I knew the password there. And then I've seen this new guy there, and so I introduced myself that I am working here, and he said that he just arrived, and he told me that he was working at an NIH, and he wants to develop a HIV vaccine, and he worked with Tony Fauci. Didn't ring a bell because I was not in that field, and so I didn't know who was doing vaccine research, and Drew was saying that he wanted to do vaccines and try different things, and I like to brag, and I brag about that. Oh, I make RNA, I can make RNA, and if you want, I can make it for you. And it was not by accident. By that time, maybe he was the 30th person I was offering to make RNA, because I gave other people, and one or two person, used it and published it, and I was also part of it. But most of the people, I just offering, oh, I can do. They said, yeah, because I was like pushing it and maybe probably still in their freezer, never used. But some people tried and didn't work out, and they told me so. But it was different with Drew because he tested out immediately, and I made a HIV-specific protein coding RNA, and he gave me the gene, and I cloned into the right cassette and made RNA, and he was so happy that this works. So all of this immunological marker went up. Perfect vaccine, so much protein was made, and he was very enthusiastic about it. He said all of these inflammatory markers. I said, oh, that's not good for me. I don't want inflammation. I injected into the brain. Maybe that is also, I did not see any effect that the RNA is not good, which I was doing. And I could see only when Drew tested out on immune cells, human immune cells. And then he added RNA, and these human immune cells made a lot of inflammatory molecules. And that was, I was worried. And today we know also that the human is much more sensitive to conventional RNA than the animals. So I did not see on animals the effect. One question was that why it is inflammatory, and that's we identified that it was uridine in the RNA actually. At that point, first we did not know. We just try to understand. Okay, first we try to understand why it is inflammatory, because it's coming from outside. So those RNA, which is inside the cell, is not inflammatory. So what we decided that we isolate those RNA, which is inside the cell, isolate, and now try to put on the immune cells, human immune cells from outside. Is it inflammatory now? You understand? So it mimicking like you have an injury when you are just damaging your own cells. And we imagine that things are coming out from the dead cells, and immune cells are reacting for that. And this is really what happened. So the human immune cells reacted, and they did the inflammatory molecules. What was surprising is that tRNA, transfer RNA, did not induce any inflammatory molecules. And knowing that the tRNA has the most modified nucleosides in it, we were thinking that could it be that the modification of the nucleosides is making the RNA non-immunogenic?